So basically, we are continuing with exercise 11C, question number 9. Okay. So if you read the problem, a water is poured into inverted hollow cone whose semi-vertical angle is 30 degrees. Now we are having a hollow cone. Let the diagram be big enough in your exams as well. So this is a inverted cone, right? And a water is poured inside it. We are putting water inside this particular cone. Okay. Then what is happening is the semi-vertical angle is 30 degrees. I'll explain what is a semi-vertical angle. Okay. Now water is poured in such a way that the depth which is measured along the axis, so it is the altitude or the vertical height. Okay, it is increasing at a rate of 1 centimeter per second. Okay. What is the initial depth? If you read the entire problem, what is the initial depth? Can you tell me? What is the initial depth? You can message it over the chat box. Initial depth. Have you figured out what is the initial depth? The initial depth is 24 centimeters. It's given in the problem. Okay. Initial depth is not the volume. Initial depth is the height. Height is 24 centimeter. So now see, this is water level, which is there. The blue color is the nothing but the water level, which is there when the height initially is, this particular height, this h is equal to 24 centimeters. Okay. Are you understanding, guys? Yes or no? Your response is very important for me. This vertical height is 24 centimeters. Let us make this a bit big. This is the water level. This is the initial height, initial radius, and initial slant height. L is the slant height. R is the radius of the water level, which is there when the depth is 24 centimeters. Okay. Now, semi-vertical angle is this. This is semi-vertical angle, and this is equal to 30 degrees. This is given. Okay. See, this entire thing is the vertical angle. This entire thing, the pink colored part is the vertical angle. And the half of it, this half, is semi-vertical angle. So guys, you understood what is the vertical angle and semi-vertical angle of a cone? The entire curve to curve is vertical angle and half of it is semi-vertical angle. Yeah. Okay. So the water is poured into a hollow cone whose semi-vertical angle is 30 degrees and the depth measured along the axis is increasing at the rate of 1 centimeter per second. So what is increasing, guys? As we pour the water into this hollow cone, what is increasing, guys? What they have given as increasing? The depth is increasing. Okay. The depth is what? Height, altitude, with regards to this problem. So dh by dt, there is a change in height. The height is changing at a rate of 1 centimeter per second. Okay, the height is changing. The height is changing. When I say changing, does it imply increasing or decreasing? Increase and decrease both indicates change, right? But then for this problem, it is increase or decrease. You have to answer, guys. The depth is increasing. Okay, it's given in the problem. So you can read if you want. So this much amount of data we have, decoded, right? dh by dt is equal to 1. Now they're asking you the rate at which the volume is increasing. Volume of the water level is increasing. So dv by dt they are asking. How the volume of the water is increasing. At what rate it is increasing. They're asking this. Okay. Right. Now this semi-vertical angle will help us in one particular instance. Okay, so look at the triangle which is formed below, R, H, and L. Okay, we have nothing to do with the slant height in this problem. Okay, we'll get rid of the R, right? Slant height, nothing is mentioned, so we'll get rid of the R. So, as per trigonometry, R, H, and 30, just focus on this, R, H, and 30. Okay, we don't have to do anything with the slant height in the entire problem. So, we'll try to eliminate R. We'll express R in terms of H. Okay, now see, tan 30. Look at the diagram. Okay, tan 30 is equal to opposite side upon hypotenuse. Okay, so which is the side that is opposite to 30? Parallelly, you can copy this. Which is the side that is opposite to 30? Guys, you have to respond. Come on. Side opposite to 30 is R. Okay, so tan 30, which is 1 upon root 3. Opposite side is R. Okay, one second. Tan 30 is opposite side upon adjacent side. Sorry, tan 30 is opposite side upon adjacent side. I'm sorry for that. So what is the adjacent side of 30? Which is the adjacent side of 30? Adjacent side of 30. Reply. Adjacent side of 30 is H. I hope everybody is looking at the triangle in the right way. So this is H. So H is equal to, sorry, R is equal to, R in terms of H we need to write. Get everything in terms of H because the problem is dependent on H. H is the very important entity in this entire problem. Height. Because the rate of change of height is given, initial height is given. So we have to scrap out R, we have to scrap out L. Okay, slant height. Fine. Okay. So R is equal to H by root 3. So this much amount of information I have decoded. We have decoded. Right? Now we have to find out the change in volume dV by dt that we need to find out. So volume of the water inside the cone. Okay, volume of the water which is there inside the cone will take the shape of the cone itself. The water level will take the shape of the cone itself. The entire water which is there inside the cone, it will take the shape of the cone itself. Okay, so the volume over here is 1 by 3 pi r square h, volume of the cone. Volume of the water inside the cone. Volume of the water inside the cone is nothing but in a conical shape. I hope you can imagine. Okay, now put the value of r, replace r. What is r? R is h by root 3. R is h by root 3. Okay, so h by root 3, the whole square into h, which is pi by 3, h square by 3 into h. So volume is equal to pi by 9 h cube, pi by 9 h cube. Now the volume changes because the height changes. Volume changes because the height changes. So we are going to differentiate this both the sides with respect to anyone? With respect to changes occurring with respect to time. dy dt of v, dy dt of pi by 9 h cube, pi by 9 h cube. Okay, dy dt of v is nothing but dv by dt. Okay, I'll go to the previous slide. d by dt of v is nothing but dv by dt. Okay, pi by 9 will go outside being a constant. Pi by 9 d by dt of h cube, d by dt of h cube. So dv by dt is equal to pi by 9 3h square d by dt of h. Okay, so this is x raised to n formula. Okay, or rather t raised to n formula. So when I compare this with t raised to n, who is t, t is h. Chain rule will also come. So dv by dt is equal to pi by 3. Okay, this 3 ones are and 3 threes are h square dh by dt. Now we know the value of initial height. Initial height is 24 centimeters. So this is 24 square and dh by dt. We have noted down dh by dt is nothing but 1 centimeter per second. So this is 1. Okay. So if you calculate this, keep pi as it is. They are not asking us to take pi as 22 by 7 or 3.142. Nothing has been mentioned. So keep pi as it is. So if you solve this, 24 square upon 3. So you'll get 192. Okay, 192 pi. So the final answer will be dv by dt is equal to 192 pi. It's volume, right? So centimeter cube or cubic centimeter per second. Per second. Per second. Okay. Yes. Have you understood the problem? The change in volume, how the volume is increasing. Have you understood this? Feedback, feedback. Come on, please tell me. Hello. Okay. Next problem. That is question number 13. Okay. So reading the problem is very important. Otherwise, we won't understand anything out of it. I hope everybody copied this. Yeah. Question number 13. Similar problem, but then few things will change. Water is dripping out of a conical funnel at a uniform rate of 2 centimeter cube per second through a tiny hole at the vertex of the bottom. So see, basically we are having a conical funnel. Okay, water is falling outside. Okay, and the water is dripping out at a rate of 2 centimeter cube per second. So these droplets are falling at a rate of 2 centimeter cube per second. Now centimeter cube is nothing but volume. So each water droplet will be falling at a rate of 2 centimeter cube per second. So this water droplet will take the shape of the cone because it is falling from a cone at a very initial point or instantaneously, I should say, in physics terms. So dv by dt is equal to 2 centimeter cube per second. The water droplets are falling outside this conical funnel at a rate of 2 centimeter cube per second. That is given. Okay. When the slant height of the water is 4 centimeter. Now, initially the slant height of the water is 4 centimeter. Find the rate of decrease of the slant height of the water when the vertical angle is 60 degrees. Okay, so now see, this is the water level initially. Okay, so this is initial R, initial H, and initial L. So initial L is equal to 4 centimeters. That's given in the problem. Okay, right? Now the vertical angle is 60 degrees. Guys, we are interested in vertical angle or semi-vertical angle. Please tell me that. It will tell me what you have learned from the previous problem. Please reply. Correct. Water is the angle is semi-vertical angle. Okay. So can someone tell me what is the semi-vertical angle? Can someone tell me what is the semi-vertical angle? 30 degrees. Perfect. See, because the vertical angle is 60 degrees, the semi-vertical angle has to be 30 degrees. Okay. Find the rate of decrease of slant height. So how this slant height is changing, they are asking. So this time it will be decrease. Why it is decrease? Because the water droplets, as they go out of the funnel, the water inside the conical flask will reduce. Conical funnel will reduce. So all three changes will go on reducing. All three things like height, slant height, radius, everything will change. So they are asking what is the change in the slant height, how it is decreasing. So the most important entity in this problem becomes slant height. Okay, so our focus should be on slant height. R and H are not really very important for us. Hence, we have to eliminate R and H. Okay, so that is the first clue which I am giving you. Now, this time, instead of taking tan 30, I will be working as per sine 30 and cos 30. Because when we take sine 30 and cos 30, it involves hypotenuse. And L is the hypotenuse. Yes, some people have rightly guessed. Very good. Okay, so this time no tan 30 because we have to eliminate R and H and we have to involve L. L is nothing but slant height and it is the hypotenuse in that particular triangle. Okay, so first I will write sine 30. I'll take a new page. Sine 30 is equal to opposite upon hypotenuse. Okay, so sine 30 is half. Side opposite to 30. Side opposite to 30 is R and hypotenuse is L. Okay, so R is equal to half L. R is equal to half L. Okay, cos 30. Adjacent upon hypotenuse. Adjacent upon hypotenuse. Okay, cos 30 is root 3 by 2. Side adjacent to R. Side adjacent to, sorry, 30. Side adjacent to 30. Which is the side adjacent to 30? H. Look at the triangle and see it for yourself. That is H. Okay. Hypotenuse is L, that we all know. So H in terms of L. Now we got both the things in terms of L. We had to get both the things in terms of L because L is the most important thing over here. Because we are supposed to find out how L is getting reduced over a period of time, how the slant height is getting reduced. So this is step 2 of the problem. Step 1 is gathering data, and step 2 is pulling out some inferences using trigonometry. Okay. Yes, this is step 2. Now let's get back to volume. Volume of the water droplet which is going outside the conical flask. So it will take the shape of the cone. So volume is equal to 1 by 3 pi r square h. Okay. So this is pi by 3 r. Now what is r in terms of L? Is half L, and h is 3 root 3 by 2 L. Put the value of r and h. This is half L and this is root 3 by 2 L. So V is equal to pi by 3, 1 by 4 L square root 3 by 2 L. So V is equal to root 3 pi upon 24 L cube. Root 3 pi upon 24 L cube. Now the volume is changing over a period of time. It's given in the problem dV by dt. Volume changes because the slant height also changes. So differentiate with respect to t on both the sides because the changes are occurring over here. Okay, so dV by dt is equal to root 3 pi by 24. 3L square d by dt of anyone? Here applied x raised to n, that is t raised to n formula. But then chain rule will come. D by dt of L, correct. D by dt of L. Okay. So dV by dt equal to root 3 pi by 24. Okay, I can cancel this out, so I'll do that. 3 ones are 3 eights are. So root 3 pi by 8 L square dl by dt. Root 3 pi by 8 L square dl by dt. Fine. Now we know the value of L, we know the value of dl by dt. So the initial value of L is 4 centimeters, right? And we know the value of dV by dt, that is 2. So this is 4 square dl by dt. Okay, and dV by dt is 2. This is 2. Okay, so 16, 8 twos are 16, root 3 pi into 16 dl by dt. Okay, so 16 and 16 will get cancelled on both the sides. This will be 1, and then you can cross multiply root 3 pi on the other side. So dl by dt is equal to 1 upon root 3 pi. Dl by dt, this root 3 pi will go down over here. 1 upon root 3 pi. Now this is L, so it is centimeters per second, second, minute, whatever that will be mentioned in the problem. For this problem, it is in seconds, the time. That is the end of the problem. Okay. right? So guys, can you just share a feedback on the understanding of this particular problem? Have you understood this? Any feedback? Please tell me. Okay, great. Let us go to question number 17. Question number 17. Okay. Now question number 17, sub question 1 is self-study. It is exactly similar to question number 13. It is exactly similar to question number 13. Okay. Is it similar? Can you read and tell me? Is it similar? Decrease in the slant height of the water. Question number 17, sub question 1. Yes or no? Please respond. I'm just waiting for your confirmation. Okay, fine. So I take it yes, we have understood the first part. The second part. For the second part, we'll draw this diagram. Okay, it is exactly same as the previous problem. Question number 13, the diagram is same. Okay, there is water which is dripping out from this conical flask. Question number 17, sub question 2. Okay, again we have a conical flask over here. The water is dripping out. Okay, so dV by dt is equal to 1 cubic centimeter cube per second. Okay, the initial slant height. So there is some water present inside this particular flask. So this is the initial value of R, initial value of H, initial value of L. So initial L is 4 centimeters. Okay, I'm solving the second part of the problem. What is the semi-vertical angle over here? Semi-vertical angle. If you're reading, you will understand. What is the semi-vertical angle over here? Please reply. 30 degrees. The vertical angle is 60 degrees. So the semi-vertical angle is 30 degrees over here. Okay. Now they're asking you in the second part, find the decrease in the area of the water surface. So water surface, this is the water surface, right? This is the water surface. As the water droplets go out of the conical funnel from the tip of the cone, inverted cone, this water surface will increase or decrease? Logically answer, please. It will increase or decrease? Please tell me. The water surface. When we look from the top, the water surface will increase or decrease. Obviously, when the drops move out from the bottom, this water surface is going to decrease, right? I hope you can imagine that. Okay. So this time we are more concerned about the area of the water surface. So dA by dt, we are supposed to calculate in the second part. The first part is exactly similar to the 13th question which we have done. We are solving the second part. Okay. Now see guys, area of the water surface. So what is the area of the water surface? Can you tell me? The area of the water surface will take which shape? Area of the water surface will take which shape when you look from the top? The area of the water surface will take which shape when you look from the top? It will take the shape of the circle. When you take a view from the top, it will take the shape of a circle. Okay, so that is pi r square. Okay, so now the important thing over here is area, right? Because we are supposed to find out the decrease in the area of the water surface, right? So now first of all, okay, trigo, like the previous problem, L is given. We need to find out R, okay, or convert the entire problem into L. So look at the triangle over here, R, H, and L, and 30 degrees. So sine 30 is equal to opposite upon hypotenuse. Half is equal to R upon L. Opposite to 30 degrees is R, hypotenuse is L. Okay, so R is equal to half L. Okay, so put that value over here, half L the whole square. So A is equal to pi 1 by 4 L square. So A is equal to pi by 4 L square. We simplified the area. We got it in terms of L. Now the area changes with respect to time. Now the area changes with respect to time. So the differentiation part will be done with respect to time. So we'll have to use d by dt on both the sides. d by dt of A, d by dt of pi by 4 L square. So dA by dt, take pi by 4 outside, d by dt of L square. So dA by dt, pi by 4, 2L, d by dt of L. d by dt of L. Okay. Yeah. Now we have these values of L and dL by dt. Initial values we have. Initial slant height is 4. Okay. And the water is dripping out at a steady rate of 1 cc per second. That is also given. Okay. So you can put ls 4 over here, and dl by dt you can substitute from the first part of the problem. You can substitute this from the first part of the problem. Okay. First part I have given it for self-study. It was same like question number 13. So this is how you have to complete the problem. Yes, guys. Have you understood this? Have you understood this? Yes or no? The first part of the problem will give you DL by dt. That you can put it over here. Will you kindly respond? Okay. I'll take you to question number 16, right? Question number 16. Yes. It's a bit different from the previous problem. Yeah. The radius of the base of a certain cone is increasing at a rate of 3 centimeter per minute, and the altitude is decreasing at a rate of 4 centimeter per minute. Find the rate of change of the total surface area of the cone when the radius is 7 centimeter and altitude is 24 centimeter. So we have a cone. Once again, the last problem based on cone. Okay. So this is base, this is height, and this is slant height, L. Okay. Now the radius of the base is increasing. So dr by dt is increasing at a rate of 3 centimeter per minute. The height is decreasing, the vertical height, dh by dt. It is decreasing at a rate of 4 centimeter per minute. So this is minus 4. Minus indicates decrease. It's mentioned decreasing, so it is minus 4. So the initial value of R is 7 centimeters to be precise, and initial value of H, altitude is 24. Okay, so this information is given to us. Okay, now they have given find the rate of change of total surface area of the. So they are asking dA by dt. How the total surface area is changing. Okay, yes. Now see, one thing is there is no vertical angle or semi-vertical angle mentioned in the problem. So we have to rely on something else. How are H and L are related? Can someone tell me? How are H and L are related? They are related by Pythagoras theorem. R square plus H square is equal to L square. Okay, so 7 square plus 24 square is equal to L square. So the initial length will be 25. Initial slant height will be 25. When the radius is 7, depth or the vertical height of the entire cone is 24. The slant height will be 25. And remember, the radius is increasing, but then the depth is or the height is decreasing. It's mentioned in the problem. We have to find out change in the area. Which area? Area of the entire surface, total surface area. Okay, so this information is given. Now see, total surface area of a right circular cone, that is A, okay, equal to pi RL plus pi R square. Differentiate with respect to time, dy dt of A, dy dt of pi RL plus dy dt of pi R square. dA by dt, pi goes outside, dy dt of R into L, pi goes outside, dy dt of R square. Now R, L, H, everything is changing. So R, L, and H are not constants, they are changing. Okay, so here I am going to apply U into V rule, and here chain rule, x raised to n formula and chain rule. That is t raised to n. Copy this much. The total surface area of a cone is pi r L, that is curved surface area, plus area of the base, that is pi r square. Base is the circle for a cone, so that is pi r square. Differentiate with respect to time on both the sides. Okay, yeah. So I hope everybody has copied till here. dA by dt is equal to pi, fine. Put a box bracket and apply UV rule. L dr by dt plus L d by dt of R plus R d by dt of L. Okay, plus pi into 2R d by dt of R, t raised to n formula. 2R d by dt of R. Okay, now we need to be very careful. So this is equal to pi. Okay, L, initial value of the length is slant height is 25. dr by dt. dr by dt initial value is 3. Initial radius is 7 into dl by dt. Change in the slant height we don't know. Plus 2 pi. Initial value of radius is 3. Okay, and initial dr by dt is initial value of the radius is 7. Sorry, and initial dr by dt is 3. I repeat, initial length is 7, slant height. Dr by dt, it's given in the problem, we have noted it down, 3. R is 7, initial R, and dr by dt is 3. We don't know what is dl by dt. Fine. So pi into 75 into 7, okay, plus 42 pi. 14 threes are 42. Now L, we don't know what is L. L is changing. Don't put the value of L as 25 over here. Over here, don't put the value of L as 25. L is changing. So directly you cannot put 25 when there is changing d by dt. If it is there, don't put the value of L. Okay. So now let's go back to the slide number 1. Can I say L is equal to root of h square plus r square? Can I say L is equal to root of h square plus r square? Yes. So here I'll just put h square plus r square. L is h square plus r square. Capital U. Now here we are going to derivate. This will be a bit complicated if you don't be attentive. So this will be pi 75 plus 7 into 1 upon 2 root h square plus r square into dt of h square plus r square. So just write it down. 7 upon 2 root h square plus r square dt of h square plus r square. Chain rule. Plus 42 pi. Plus 42 pi. Okay. So pi 75 plus 7 upon 2 into, okay, put the values of r and h. H is 25, 24, r is 7, divide dt of h square, 2h, divide dt of h plus 2r, divide dt of r plus 42 pi. Every bracket is very important over here. Every bracket is very important. So pi 75 plus 2 into 25. This value is 25. Don't take negative value. Okay. Now this becomes very crucial. See. Okay. What I will do is I'll take this two common outside the round bracket. Okay. This two I have taken common. Now h is 24 dh by dt. dh by dt in the problem is minus 4 r. This r is 3, r is 7, sorry, and dr by dt. dr by dt is 3. Okay. So this 2 and this 2 will get cancelled. Okay. And this will be minus 96 plus 21. Minus 96 plus 21. Please go through these recordings again and again so that you are comfortable with the entire exercise. Calculations for this problem are a bit different and difficult. So 96 minus 21. Okay, that's minus 75. So pi 75, 7 upon 25 into minus 75 plus 42 pi. Pi 75 plus 7 into minus 3. 25 ones are 25 threes are along with a minus sign plus 42 pi. Pi into 75 minus 21. That is 54 plus 42 pi. So this is equal to 96 pi. If you add this to this will be 96 pi. Since we are talking about area, change in the area, we are calculating dA by dt. This will be centimeter square per minute. This problem is in terms of minute. Centimeter square per minute. Okay. I would recommend go through this particular session once again so that you know there are few issues with respect to understanding. You can also ask doubts when you are back offline. Yeah, last problem. With this particular exercise is getting over. Okay. Question number 11. A kite is 112 meters above the ground. Okay. So this is a kite and it is 112 meters above the ground. Vertical height is 112 and has 130-meter string out. Okay. So the person who is flying the kite is over here. So this green colored part is the string out. String out of the kite. The star is the kite. So this is 130. Okay. Right. If you're reading the problem clearly, you'll understand. If the kite is traveling horizontally at 8 meter per second, okay, so kite moves from here to here horizontally at 8 meter per second. So this is the new position of the kite. Position 1 is the old position, position 2 is the new position of the kite. The person is stationary, he is standing at the same place. Okay, so this is the new string out. New string out. Okay, what will be the vertical height? Can someone tell me what will be the vertical height? Vertical height will remain the same because the kite is moving horizontally from point 1 to point 2. Okay, so I'll just draw the base over here. Fine. So let this be O, let this be AB, let this be PQ. Okay, H is the height which is fixed. It is not changing. Height is not changing. The string out changes. Initial string out is 130. So let the string out be Y. Okay, and let initial OB be X. Okay, so the kite is moving horizontally at 8 meter per second. Horizontal is as per the red color line. You can consider the bottom or the top. So OB is changing, X is changing. So dx by dt is equal to 8 meter per second. The kite is moving horizontally. Height is remaining the same, 112. The string out is changing. The green color part is changing. Okay. And what is given? The height, the kite is moving horizontally at 8 meter per second. So the horizontal thing in this entire problem is OP and OQ. So the initial OB is X. So X is changing horizontally. dx by dt is 8 meter per second. Okay. Now as per initial conditions in triangle OAB. Okay. OAB. Just refer OAB. X square plus H square is equal to Y square. X square plus H square is equal to Y square. X is the horizontal distance. H is the vertical height which is constant. Y is the string out. Only X and Y are changing over here. Okay. Let's put the initial values. What are the initial values? X initial value we don't know. H is 130. Y is, sorry, H is 112 and Y is 130. So if you solve this, the value of X will be 66 meters. So this is the initial value of X. Now X is changing, horizontal distance is changing. This distance is also given to us. dx by dt is 8 meter per second. Okay. Height remains constant. It is fixed. It is not changing. Y is also changing. So there is a change in y, d by dt of y. So they are asking d by dt of y. Okay. At what rate the string out is changing? What is the rate of the string out? String out is nothing but the green colored part, which I have explained in the diagram. So the y is changing, x is changing, but h is not changing. Okay. We got the initial value of x as 66. Next step. Now x square plus x square is equal to y square. Differentiate with respect to time on both the sides. d by dt of y square. X is changing, so d by dt of x square is 2x d by dt of x. Can someone tell me logically what is the derivative of h square? Logically, think, common sense. Please tell me. Very good. I got some answer. 0. Perfect. Height is not changing, so height is a constant. Okay. And d by dt of y square, y is changing, so 2y d by dt of y. Okay. Perfect. I got the perfect answer for d by dt of h square. That is 0. Height is not changing, so why to derive height? It's a constant, so it is 0. Okay. Yes or no? So 2x dx by dt is equal to 2y dy by dt. 2 will get cancelled on both the sides. Initial value of x is 66. Dx by dt is 8. Initial value of y is 130. Dy by dt we don't know. That is what we are supposed to find out. Okay. So dy by dt 66 into 8 upon 130. Okay. So that you can divide and calculate the answer. 66 into 8, as I can see on my calculator, it is 528 divided by 130. 4.0615. Okay, meters per second. Okay, because y is the string out. It is the distance between the person who is flying the kite and the kite, the hypotenuse. Okay, so that completes this particular exercise.